Hello, in this video we're going to work through this question that was on our most recent test. It's really checking two main ideas, and it involves a third concept which regularly comes up. So the first thing I want to make sure we're comfortable with is our cosine law. The second thing that we're checking is that, do you understand how to apply bearings? And the third thing is this involves our speed distance time relationship. So speed is equal to distance over time. And again, if you ever forget what this relationship is, just say to yourself, today I drove my car at 60 kilometers per hour. The speed is 60 kilometers per hour. While I start this, just another little side note about this. Please remember the difference between speed and velocity. Velocity has direction, speed does not. And that really becomes important when you start studying physics and such, so we might as well make sure we get that idea now. Alright, so let's dive in, shall we? So a smuggler leaves a private airfield A at 6 a.m. and flies on a 40-degree bearing at 200 kilometers per hour. The plane is detected by radar at the police airport, which is located 150 kilometers northwest of airfield A. At 6:30 a.m., the police airplane leaves its airport with the intention of intercepting the smugglers at 8:30 a.m. Determine the course, and that means the bearing of the plane, and speed of the police airplane to the nearest unit. Okay, so the first thing we need to do with this problem is draw a diagram. Whenever I'm dealing with bearings, problems that have some sort of distance or traveling and measurement of bearings, I'm rambling now, I often draw a little cross wherever I start from, because that allows me to kind of figure out if the direction is approximately right. So a smuggler leaves a private airfield A, so we'll call this A, at a bearing of 40 degrees at 200 kilometers per hour. So a bearing of 40 degrees, remember that bearings are always measured from north, and north is 0 degrees. So a bearing of 40 degrees is going to be a bearing about like that. So that means the angle from here to here will be 40 degrees. So if the plane travels at 200 kilometers per hour, it leaves at 6 a.m. and it's intercepted at 8:30 a.m. That means the time is 2 hours. So the distance the smuggler has gone traveled is 200 kilometers per hour times 2.5 hours. And the really nice thing about this we see is that the units hours cancel out. Again, a nice thing to kind of keep in our mind. Math, we often forget about this, but this cancellation of units is really important when we're dealing with physics. So that gives us 500 kilometers. So that means the distance here is 500. So the police station is located, it says, 150 kilometers northwest of airfield A. So northwest is going to be this direction, and we know this is 150. And if it's northwest, northwest is going to be partway between north and west. So that means the angle there will be 45 degrees. Let's make this a little bit longer. So I now run this line across here. There we go. That is where they're going to meet. So this is airfield A. Let's call this the police station P. And then let's call this location I for interception. Okay? So if we want to know the speed of the police airplane and the bearing, we need to figure out a couple things. Let's start with the speed. So if we can find distance A, what that means is I'll know how far the police plane has traveled, and I know the police plane has traveled for 2 hours, so then I can find the speed. So the first thing I'm going to do is I'm going to find A. And of course this is a side angle, side case, which means I can use cosine law, which is great. So A squared is equal to 150 squared plus 500 squared minus 2 times 150 times 500 cos of 45 plus 40, going to be 85 degrees. So A is approximately equal to, and again, I want to be able to do this in my calculator in one step. Developing good calculator techniques is so important. So we get A is approximately 509.34 kilometers. So step 2, we need to find the speed. So we know that speed is equal to distance over time, so therefore speed is approximately going to be 509.34 divided by the time, which is 2 hours. Let's put the units here, because notice kilometers per hour, my units work out. So we get the speed is approximately 254.67 kilometers per hour. So now we've solved for the speed of the plane. Now we need to find the bearing of the police plane. So let's take a look at this diagram and make sure we understand where the bearing is the measurement of. So what I'm actually interested in here, and I'm interested in this section right here to find the bearing. And so what I'm going to do, and this is helpful sometimes, is I'm actually going to draw this in an enlarged format. So I'm actually going to take a second. So we have this line here. So this is P. Now I can draw some more things on this diagram. So I need to figure out some angles. First thing I can figure out quickly from this diagram is I see there's a Z pattern here, so we know the angle here is 45 degrees. And now, if I'm interested in the bearing is the measurement from here to here. So what I need to find is I actually need to find this entire angle here. And it turns out I can do this using Sine Law. Let's change our colors. So my pair that I have in the diagram is I have length A and I have angle A. I have length small p, so I want to find angle P. So therefore we can say sine of P over 500 is equal to sine of 85 degrees over A, which is about 509.34. And now I can do some math here and I can get this. I can say P, actually let's break one intermediate step here so we see what's happened. Sine P is equal to 500 times sine of 85 degrees all over 509.34. And now I should be able to get P in one step here. So P is approximately 77.94 degrees. So we know there to there, 77.94 degrees. So now if I want to find the bearing, I can use a little bit of common sense here. So I could say, well, this is 45 degrees here. That's pretty easy to figure out. So I can say the bearing is 180 minus 45 minus 77.94. So the bearing is equal to 180 degrees minus 77.94 minus 45 degrees. So the bearing is approximately equal to 57.06 degrees. So therefore, the police plane traveled at 254.67 kilometers per hour at a bearing of 57.06 degrees. Now that I've finished this, I've noticed that the main concepts forgot to include sine law. I hope this video helped. As always, feel free to ask questions.